Okay, a container filled with 4 moles of hydrogen gas at 25 degrees Celsius. Calculate the translational kinetic energy of hydrogen molecule. Total translational kinetic energy of the hydrogen gas. Average kinetic energy of hydrogen gas. And also internal energy of hydrogen gas. Okay, we must see the keywords here. Okay, see the keywords here. First of all, he gives us the number of moles, and hydrogen gas is diatomic. Okay, diatomic. The total degree of freedom for each molecule is 5. Okay, because it's 3 plus 2 lah. 3 from translational, 2 from rotational. Okay, diatomic. Temperature already give you 25 degrees Celsius, but you have to change to Kelvin. This one must change to SI unit. Remember, SI. I write SI unit. Okay. So, okay. First, look at the first question. Question A. Now we build the equation first. I always like to build the equation first. Use this one. Yeah. I always build from the basic concept of this one. One molecule, and 1 degree of freedom. The kinetic energy is only half kT. Half kT. So if you want to find, let's say, kinetic energy for, I start with half kT. Let's say I want to find kinetic energy for F degree freedom, more than 1 degree freedom. You have F amount of degree freedom, and then you have more than 1 molecule. Then you multiply N. Understand? So this is how we do it. Okay, so we check one by one. Yeah, we always check these two things. How many degree of freedom is it, and then how many molecule it involves. Okay, how many? So I put this over here. Okay, okay, yeah. I can, maybe I should write something here. Okay. So always like this. Yeah, you always ask yourself, how many degree of freedom? The question asks, and then how many molecules are there? Okay, then we can find the total kinetic energy for all these molecules and all these degree of freedom. Okay, in fact, yes, okay, one will write something more. This half kT is only for kinetic energy for 1 molecule and 1 degree freedom. Okay, kinetic energy for 1 molecule for 1 degree freedom. So you have many molecules, you just multiply N. You have many degree freedom, you just multiply F. Okay? Okay, so go back to this one. Question A. So that is the concept just now. Okay, I'm talking about the concept just now. Okay, this is a concept. Now question A. He wants the translational. Okay, good. He wants a translational. That means the degree freedom is only limit to 3. Because translational is XYZ. It's not rotational. It's translational, so it's only 3 degree freedom. And then translational kinetic energy of hydrogen molecule. He's not hydrogen gas. It's hydrogen molecule only. Molecule. Molecule, that means only 1 molecule, n equal to 1. Yeah, the molecule is only 1 molecule. This is only 1 molecule. Okay, the first one is only for 1 molecule. Okay, be careful with the wording. You see, the question A is only 1 molecule, but the second one it asks about total, and for gas. This one is many molecules. Question B is for many molecules. You got the word total, but for hydrogen gas means as many molecules. So this one it has how to write? I should write this one as n molecules. for question B. Question B got n molecules, got many molecules. Okay? Okay, never mind. Let's do the question A first. Question A, so okay, I want to find the translational kinetic energy for one molecule. So kinetic energy, okay. So I start with half kT, yeah? I start with half kT. That is for kinetic energy for one molecule and 1 degree freedom. Okay, now, how many degree freedom are there? How many degree of freedom? 3 only, right? So multiply 3. Okay, my F is 3. My F is 3. And then my N, how many molecule? How many molecule? For N, how many molecule? 1 molecule. So I multiply 1. Understand? Only 1 molecule. So my answer is 3 over 2 kT. 3 over 2 kT. Okay? 3 degree freedom and only 1 molecule. So that's why the equation is 3 over 2 kT. So my temperature is, what's my temperature? My temperature is 25 degrees Celsius. I need to change to Kelvin. So I must plus 273. Plus 273. I cannot maintain as degrees Celsius. Must be in Kelvin. SI unit. SI unit Kelvin. So this temperature is actually let's plus and get 273 plus 25 degrees is 298. Is 298 Kelvin. Okay, 298 Kelvin. Okay, good. So now let's continue. Let's continue. This is a 3 over 2K. What is a K? Check your list of constant. K, you can check your list of constant is 1.38 exponent negative 23. Okay, this K value, use the value in the list of constant. Don't use the K value in your calculator. In the exam, it provide you this list of constant, so you need to use the value in the list of constant. Don't use, I know we have K value in the calculator. Don't ever use the K value in the calculator, because the exam give you this list of constant sheet, means it expect you to use the value here, not use the value in your calculator. Understand? It give you the list of constant here, so you should use the constant value here. Because if you follow, because the answer scheme formula, the final answer in the answer scheme, you always use the value in the list of constant. You don't use the value in the calculator. That's why if you use a value in the calculator, then your answer will be different from the answer scheme. Okay, because the answer scheme always stick to the value in the list of constant provided in the exam. Okay, always use this value here. Don't use a value from calculator. Yeah, although you can find this value from your calculator, don't use it. Use the value from list of constant. Okay, so K is 1.38 exponent negative 23. Okay, so it's 1.38 exponent negative 23. Okay, all right, that's right. And then what's the temperature? Temperature is 298 Kelvin. And let's calculate. Let's calculate the answer. Okay, so my answer is 6.17 exponent negative 21 joule. Okay, that's my answer. Is it correct? Is it correct? 6.17, yes. Exponent negative 21 joule. That's correct. Okay, that's correct. Okay, that's correct. So that's my answer. Okay. Okay. Now B, question B. Total translational kinetic energy of hydrogen gas. That means it has many molecules and n molecules. Total molecules. Total. You see the word total? The word gas means it's not just one molecule. Not just one molecule. It means it has many molecules. Okay. But the degree of freedom just stick to translational. You see that? Translational. So the degree of freedom is not 5. Although it's diatomic. I know it's diatomic. The total degree of freedom is 5. But the question just stick at translational. So the translational degree of freedom is just 3. So you still maintain as 3, not 5. Yeah? Unless there's no word of translational here. Then you put degree freedom 5. But there's a word translational here, then you have to stick to degree freedom 3 only. Okay? Okay, so let's do it. Yeah, let's do it. Question. This question. Question B. Yeah. So I want to find the total. I put a word total here. Total. So I start with half kT, which is the kinetic energy for 1 degree freedom and 1 molecule. So how many degree freedom are we talking here? 3 degree freedom, because translational only. So I multiply 3. How many degree freedom? 3. So I put 3. How many molecules? How many molecules? Don't know. I just put n lah. I just put n. Okay. Never mind. Just put as just now. Yeah lah. 3 translational. And then this is the, we don't know how many molecules, isn't it? We don't know how many molecules, so we just put as n. We just put as n. But it did give us the number of moles. You see that? Number of moles. So what should you do is, so I know the total molecules, so never mind. So this is the formula become 3/2 NKT. Do you see that? 3 go into here, so become 3/2 NKT. So what does this tell you, the NKT? You can change to number of mole, isn't it? We know PV equal to NKT. PV also equal to nRT. So we can, you know, these are brothers. NKT is actually nRT. So we can use the number of mole here. So this one is 3/2 nRT. I change to nRT, so I can use the number of moles, even though it's not provided the total molecules, the n moles. But actually, you don't know that if you want to use NKT also can. You just use the you find first the total molecules by using the number of moles multiplied by Avogadro constant. You also can find the n, big N. Then you can use NKT also can, no problem. But we want direct. We don't want two-step, right? So we just directly use nRT straight away. Okay, easier. Okay, but NKT also can be used. Okay, now let's continue. Okay, this is 3/2. We have how many moles there? How many moles? 4 moles. 4 moles. Okay, 4 moles. And 8.31, R is 8.31. Also, remember, always use back the value in the list of constant. Don't use the value in the calculator. Okay, because answer scheme always follow the list of constant. Okay, the temperature. What's the temperature? Temperature is 225 degrees Celsius. I already got just now. Plus 273 is 298 Kelvin. So 298 Kelvin. SI unit. Yeah, let's calculate. Let's calculate now. Yeah. So what's the answer? Yeah. What's the answer? Okay, 4 times 8.31 times 298 multiply 3 divided by 2. So I got the answer. Kinetic energy is 1.461. 1.461 exponent 4 joule. Exponent 4 joule. This is the total kinetic energy for whole gas. For the whole gas. So is it correct? Yes. 1.4 8.27. Why a little bit different? It should be exponent. Yeah, correct lah. Maybe a little bit different because why? What's wrong? What's wrong? Should be correct lah. Yeah. Okay. It should be correct. 14.86 exponent 3. This one is 1.46, which is 14.61. Also correct lah. Why a little bit different? because maybe let me see. Let me see. Oh, I realize. So the answer is a bit different because this time it used 273.15. This one, the temperature here, he used what? He used 273.15. So the temperature becomes what? Becomes 0.15 Kelvin. So he used the temperature 273.15. So the answer becomes what? Becomes 1.486 1.48, or we can say 1.487. 1.487 exponent 4. Then become more accurate, right? Because you use 273.15. And for this one, okay, for this one, okay, if I use that one, okay, 1.38 exponent negative 23 times 298.15 times 3 divided by 2, I get so if this one I use 298.15 Kelvin, more accurate one, I also get roughly the same lah, 6.172 exponent negative 21 joule. Okay, so either you use actually either the temperature you plus 273 or you plus 273.15 for the Kelvin. For the Kelvin, both accepted lah. Both can be accepted. Both can be accepted. So just differ by a bit lah. This one I noticed it used the 273 Kelvin. Okay, it used 273.15. Plus 0.15. That's why the answer a bit different. Okay, so now let's go for the next questions. Question C. Let's do the question C. Question C. Now I want to find what's my keyword. Let's look at our keyword. Our keyword is it must be average. The word average kinetic energy of the gas. Even though he said gas here, but the average means what? Average means what? Average means average means what? Okay. I want you to pay attention. What average it means? One molecule. Average it means one molecule. Remember this. Only one molecule. Even though he put gas. Even though he put gas. So, but the word average here, it means as average. As average, each molecule has how much kinetic energy? This is what it means. As average, each molecule, one molecule, as average in the whole gas, each molecule has average of kinetic energy, blah 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 blah. Okay, this is what it means. Each molecule, average. Okay, even though he has the word gas, but it doesn't mean the total molecules. It doesn't mean all the molecules. Is the word average. It means as average, each molecule in the gas. Maybe I should write like this. Maybe I should write as average. Each molecule in the gas. Okay. Each as average. Each make it bigger. The wording. Yep. Like that. Okay. As average, each molecule in the, even though he said in the gas, average. Each molecule in the gas has kinetic energy what? Yeah. So this is what it means by the average kinetic energy. Yeah. The bracket, it means the bracket here, it means, you know, the bracket. The bracket here, it means what? It means average or mean kinetic energy. It means one molecule. Okay. As average, each molecule, that means only one molecule. The kinetic energy of one molecule in the gas as kinetic energy. Okay, so this is only one molecule. The question C is only one molecule. One molecule. Okay, one molecule. But the thing is, here he says kinetic energy. Kinetic energy. No translational word. No wording of translational. So no wording of translational. That means the total degree of freedom is 5. See that? Because hydrogen is diatomic, and no translational word here. So the F degree freedom now we use as 5 degree freedom. Okay, 5 degree freedom, but one molecule. Okay, so the F degree freedom here you put 5, molecule here you put 1. Okay. Okay, so now let's do it. So we write because you got the word average here, so your symbol is like this: average kinetic energy. Okay, we start with the half kT energy for 1 degree freedom, 1 molecule. Okay, how many degree freedom are we talking? 5 degree freedom, because no translational word. Means it's a diatomic. Hydrogen is diatomic. So 5 degree freedom. So we multiply 5. How many molecules? Only one molecule, because got the word average. Got the word average means only one molecule. We are talking only one molecule. So we multiply 1. We multiply 1 molecule. So our equation is actually 5/2 kT. That's it, 5/2 kT, and we can find the answer. 5/2 kT. What's the value of K? K we can find from list of constant. 1.38 exponent -23. 1.38 exponent -23. Okay. So temperature. What is the temperature? Temperature is 298.15 Kelvin. 298. You want to put 298 only also can. You want to put 298.15 also can. Yeah, both accepted. 298.15 Kelvin. Must change to Kelvin. Don't put degree Celsius. Okay, so let's calculate the answer. Yeah, let's calculate the answer. 1.38 exponent -23 multiply by 298.15 and multiply 5 divided by 2. So my answer is is 1.03, yeah, 1.03 exponent -20 joule. Okay, the answer here is wrong. It's wrong. It's because it should be one. This is only one molecule. The answer given is all molecules. It should be actually the word average here. It means one molecule. Okay. You can do more reference. The word average here always refer to one molecule. Always refer to one molecule. So this one, the answer should be my answer. Yeah, should be my answer. So you can ask your own lecturer, clarify this. But I'm sure the word average here, it means for only one molecule. Okay, so this one is should be 1.03 exponent -20 joule. Okay, That's the correct answer. Now, talking about the internal energy of the hydrogen gas, so this internal energy is the whole gas lah. The internal energy. So how to do that? Okay, so questions for this is for all molecules. Yeah, for question D, put it here. So internal energy is U. U, internal energy of gas. So internal energy of gas is actually the total kinetic energy of gas. Total kinetic energy of gas. That means it has all molecules. Yes, N molecules. And also he didn't say this one means a 5-degree freedom. Yeah, not translational only. Yes, rotational as well. So it has 5-degree freedom. So let's do it. So the total kinetic energy of gas. So start with half kT. How many degree freedom? Multiply F and multiply N molecules. Okay, N molecules. So how many degree freedom? You have 5-degree freedom, isn't it? 5-degree freedom because it's a hydrogen gas. 5 diatomic. You have N molecules of the whole gas. So this is F over 2 become F over 2 NKT. F over 2 NKT. Okay, but we are given only the number of moles. So we can change it to nRT. Can change it to nRT. 5 over 2 nRT. So we substitute the N. The number of moles is just 4 moles. Okay, 4 moles, and then 8.31. And then this is 298.15. Okay, so let's calculate. Yeah, let's calculate. Okay, multiply 5 divided by 2. So yes, this is the okay, so the answer is 2.48. 2.48 exponent 2.48 exponent 4. 2.48 exponent 4 joule. So that's the answer. Okay, 2.48 exponent 4 joule. Is it correct? Yeah, 24.79 of exponent 3. Right, 2.48 lah, exponent 4 lah, joule. Yeah, that's correct. Yeah. Okay, so that's all. Total internal energy of gas means the total kinetic internal energy is the total kinetic energy of all gas molecules. Means you have N molecules, so you need to multiply N. Degree freedom is 5 because kinetic energy is general. Yeah, it's not limited to only translational. It has rotational as well. And this is the diatomic gas. Hydrogen is a diatomic gas, so it has a total of 5-degree freedom. Multiply 5. So that's all, and then the NKT can change to nRT to get the number of moles. Okay, so that's all for these questions. Okay, thank you and bye.